equal 1 by 2 into m1 plus m2 r dot square plus 1 by 2 into m1 into m2 by m1 plus m2 into r dot square. T equal 1 by 2 m r dot square plus 1 by 2 mu r dot square. Equation number 7, where m equal m1 plus m2 equal total mass. And mu equal m1 into m2 by m1 plus m2 equal reduced mass. Now the Lagrangian of the system is L equal T minus V. L equal 1 by 2 m r dot square plus 1 by 2 mu r dot square minus VR. Equation number 8. Now the Lagrange equation for capital R and R small r are d by dt into del L by del R dot minus del L by del R equal 0. Equation number 9. And d by dt into del L by del R dot minus del L by del R equal 0. Equation number 10. Substituting the value from equation into equation 9 and 10, we get d by dt into del L by del R dot minus del L by del R equal 0. d by dt into del by del R dot into 1 by 2 m r dot square plus 1 by 2 mu r dot square minus VR minus del by del R into 1 by 2 m r dot square plus 1 by 2 mu r dot square minus VR equal 0. Or d by dt into 1 by 2 into 2 m r dot equal 0. Or d by dt into m r dot equal 0. Or m into d by dt r dot equal 0. R dot equal constant. Equation number 11. Similarly, d by dt del by del R dot into 1 by 2 m r dot square plus 1 by 2 mu r dot square minus VR minus del by del R 1 by 2 m r dot square plus 1 by 2 mu r dot square minus VR equal 0. d by dt mu r dot plus del VR by del R equal 0. Or mu into d by dt r dot plus del v r by del r equal 0, or mu r double dot equal minus del v r by del r. Mu r double dot equal f of r, because minus dvr by del r equal f of r. Equation number 12. We see that the center of mass doesn't appear in the equation of motion. The equation of motion depends only on the relative distance between the particle. Therefore, the trim 1 by 2 r dot square in equation 8 can be neglected. L equal 1 by 2 mu r dot square minus v of r. Equation number 13, which is the Lagrangian of a particle with reduced mass. Thus, from equation 12 and 13, it can be shown that the two particle problem reduce to one particle problem.